First, I'll talk a bit about myself and who I am and why you should actually like trust me with the materials that I'm presenting. And then I will basically it's not a live coding session. Basically, it's already like materials that I'm using to teach university students and working professionals who want to like kind of like break into like machine learning and traditional NLP. And then, yeah, as I said, I will go through the notebooks and just talk about my experience and like how to best use those materials for teaching. So my name is Andreevna Chalaguine. I'm originally from Belarus. I grew up in Germany, but I've been living in the UK for the past 11 years. I did a PhD at UCL in computer science, to be specific in computational argumentation. And during that time, I did a lot of teaching. That's why my PhD took a bit longer, not because I'm lazy, but because I did a lot of teaching, and I was very good at it. So, however, academia doesn't pay really well, so I left academia, but I still enjoy teaching and like doing it, as a kind of like as a side hustle. So I have private clients. It's, as I said, either working professionals or university students who need like help with their courseworks or mentorship. For example. My bachelor was in law, and then I switched to computer science, right? So I did one of those conversion courses, and so quite often I have people, like students, reaching out to me, being like, "Oh yeah, I'm in a similar situation. Like I want like a mentor that I can talk to about courseworks, get your opinion on stuff, and or yeah, just help in certain subjects." And so this is also how those like materials came about, right? I created them for students. And then eventually I got a position as a guest lecturer at the University of Oxford in the Department for Continuing Education. And so there I run like small boot camps, like weekend courses. And this is basically like what it's tailored for, right? It's like it's materials to cover in 2 days. It had really good reviews. I launched it last year, and this year, for example, it's completely booked out. So yeah, that's me in a nutshell. And why I'm doing this. Another motivation for this was actually my brother, who worked as a data analyst in the public sector, and they were using Excel to extract data from text. Classic scenario, right? So, which is ridiculous. And I know there's like a huge hype now, for generative AI and ChatGPT, etc. But there are also a lot of people out there who don't need that, like who basically just need to learn how to, use regex or traditional ML methods, or what is also really popular, which I will not be covering here, but is, for example, named entity extraction, to know how, if you already have a dictionary of words, how you can train your own named entity classifier. So things like that. So that's what it's tailored for. No ChatGPT today, no deep neural networks, just all good traditional machine learning using scikit-learn. And so yeah. So for those who just joined, there will be no live coding. I'm presenting teaching materials that are kind of like tailored as a 2-day course, as a 2-day boot camp for people who are just getting started with machine learning and NLP. So yeah, as you see, it has like a folder structure of like day 1, and then there's a day 2. And so the very first lecture, as I said, like I usually talk a bit about myself and why you should trust me. And then I talk about, what is NLP, right? So I stole this one actually from the lecture slides of my favorite lecturer at UCL in NLP, Sebastian Riedel. Maybe you've heard of him. So I really like this one, where he's like, okay, no, NLP is not Control F anymore. I'm also not claiming that, but this is where it started, right? And still, still a lot of problems can be solved, in a way easier way instead of just, throwing a transformer model on them. And this is kind of like the philosophy I'm representing, that, first try the simple way before you do it like the very complicated hard way. Then we talk about applications in NLP. Usually I make this like a more interactive session where I ask people, where do you think you've used NLP before? Obviously, everybody has used machine translation at some point in their lives, or they know how spam detection works. So yeah, so we kind of have like a group discussion. And then we talk about challenges. Why NLP is so challenging? Well, because the data is unstructured, right? It's not like you have just, beautiful columns of numerical data. Then obviously there's ambiguity. I mean, some of these things, they apply more for generative AI, but still. And then we talk about like some examples. So again, credit to Sebastian Riedel for this one. You can't eat a dumpling wearing a tuxedo. Well, but the dumpling is not wearing a tuxedo. So, like, I'm just trying, especially, in the UK, UK is really international. I have like people who where English is their third or fourth language. So I'm trying like to make it a bit like easier digestible. Then we have lexical ambiguity that we talk about, structural ambiguity, and then there are like some really nice examples. So I really like this one. It was down for a while, but it seems like they put it back up. So what we usually do is we play a little game. It's called ambiguity game. Not sure whether you've heard of it before. So you read the instructions. So basically, yeah, but as I said, so I will let you click through it yourself. But so here, that's basically the example that they use. I can't remember from which university that is. There's also a paper here that you can read. And it's called Madly Ambiguous. And it's from the University of Washington, IBM. Okay. And so basically, the idea is to make people understand, that although structurally a sentence is the same, right? Saying, for example, Jane ate spaghetti with a fork, and Jane ate spaghetti with meatballs. It's not like meatballs are not a utensil, right? So this is like kind of fun and interactive, and I really like this one. So I'm really happy that they put it back up. And then you can basically play. So here they explain it, right? What they talk about syntactic structures, and then you can play a game. Finally, at some point. Come on. There we are. Begin. Right, and then you ask students to engage, right? And then which one I really liked is Jane ate spaghetti with lady fingers. Lady fingers are cookies, not lady fingers as little fingers of a lady. And then, yeah, see, and it doesn't get it right. Because he thinks that you're like it's the fingers of a lady, but it's actually the biscuits that you use for tiramisu. So yeah, so that's fun. What else? Then we talk about synonyms, and given I presented in the UK, I use British English as an example, what Brits say and then what they actually mean. I will not read them out loud, but you get it. Then there are some really beautiful demos from Alan NLP that you can check out. Like, I'm not gonna go over them yet, but I included some screenshots where you can, write a sentence yourself or like a passage of text and then question it and see whether they got it, whether they get it right or not. Then again, what is another challenge of NLP is actually just a change of language, right? So especially in generative models, that's a big thing. So in a couple of years ago, nobody would know what a PCR test is, right? Like, because there was just, this data was not there. Like all those big language models, right? They're trained on corpora of data. And yeah, so I like this one. So in the past, we drank way more wine and had more fun, and now everybody's like super health conscious, right? And is drinking water. So that is the Google Ngrams view. It's really fun. So obviously you can try to come up with some other examples. So I like this one. Maybe don't use it when you teach it to under 18s. And then figurative speech, so another demo from Alan NLP, and where you use sarcasm and see whether the model gets it right or not. They must have trained it, because when I just started using the example a bit over a year ago, they would think it's a positive sentence, and now he's somewhat confident that it's a negative one. I think I just used the example too often, and now they trained the model in the background. So yeah, so this is like the first icebreaker lecture that I give to students, as I said, either in a group or privately. In a group, obviously, it's more fun. Cool. Then what I do is, so I do tell people, right, that as a prerequisite, so if it's university students, not a problem anyway, because usually they already know Python. If it's people who sign up for the course that I teach at university, then I tell them that they should do at least some basic course, just to know the syntax. Like, I don't need them to know perfect object-oriented programming and how to write classes and whatever, but at least they should be comfortable with the syntax. Otherwise, you know, because it's very code heavy. Like I don't want to give like theoretical lectures where people kind of like go out and say, okay, I got it, but I have no clue how to implement it. So I give them like a lot of code that works and where they can, you know, just use their own data and it will, you know, and it will compile. So yeah, so if you don't know, like if you've never seen Python code before, probably it's a bit intimidating and challenging. But basically, I do still spend like 40 minutes. I will not do that with you guys now, though, to just go through some very basic stuff. And yeah, and obviously it's up to you whether you even include that, right? You can just say, hey, no, I don't have that much time. The prerequisite is you know Python more or less before you do this course. Cool. So that's that. Then I also have, then usually, you know, once we're done with this, to again make sure that people weren't just nodding and saying, yeah, yeah, sure, sounds good, yeah, yeah. I tell them now you have an hour to do a practical, right? So I've created a practical, it also has a solution, and then depends whether somebody, usually I like walking around, because usually it's not more than 20 people, and then there's no point like then doing it together, usually just walk around and then check in with people. And see whether, like, how they're getting along. And it's very, like, simple, you know, but it already involves a bit of text preprocessing, right? They have to read in a file, they set it to lowercase, they delete all punctuation. And this also gives you, when you actually walk around and give this, like, in a classroom setting, it also gives you an idea of, like, you know, the level of people. Yeah, then there's a solution included that people then usually can just have a look at. And then we start talking about text preprocessing. And so this is where, you know, I'm now, you know, gonna give you like some examples that I've noticed that in other NLP courses online, like certain things were missing or were omitted that I then tried to, you know, like try to include in my, well, in this little course that I've created. So for example, first we start talking about regular expressions. Yes, boring, but sometimes does solve problems. To give you an example, because I have a degree in law, I sometimes take projects on in legal tech. And if you've ever seen EU regulations, like the titles are freaking massive. And so they have abbreviations, right? And then you could either go the fancy way and say, ooh, let's train, you know, like a named entity recognizer for that, or you can actually just figure out and write a good regular expression for it. And so yeah, this is why I like also talking, you know, about that. I'm not telling people should now become like experts at writing regular expressions, but they need to be aware that something like that exists so that they can Google it, right? Also, in a second, I'll talk about text normalization, where again, like this becomes relevant. So I just tell them, yeah, look, just here are the tables. This is what you can do with it. Then run through a few examples of, you know, how to apply regex in Python, and that's it. Then I tell them, you know, most likely, you know, at the beginning, you will probably do like Kaggle challenges, or, you know, your textual data will come actually in a nice CSV file, so you should be able to at least, you know some basic pandas. Again, I'm not giving like a huge pandas tutorial here. I just say, okay, you can go away and learn it by yourself, but at least you should be able to, like, you know, read in a file, select some columns, you know, apply a function to a column, etc. So then I go over that. So nothing super special, and then we start talking about text preprocessing. And so this is what I've noticed is like very often, if not always, omitted, and I also see it in a lot of research papers that people do it wrong. We will talk about this in a bit when we start talking about baselines, that people just randomly apply preprocessing without ever verifying whether it actually does any good to your data. So it's like, oh, we set a baseline, we already removed stop words. Okay, have you actually verified that that did something good? Is it actually useful to remove stop words? So we'll talk about that in a bit. And so yeah, so basically, especially it's more targeted towards, you know, people who, you know, who are new to this and who think that there's like one way of doing it, you know. Well, there's not. It obviously depends on your textual data, whether certain decisions make sense or not. And so I use like 3 different examples here. Here we have, you know, like a spam text, a review sample, and a news sample, right? And different types of text require different preprocessing. Right? So for example, spam or Twitter data is obviously very dirty. Yeah. Then you have like a news sample, you know, which is like perfect, nice English with nothing funny going on here. And so this is where, you know, I kind of like gap the bridge to text normalization. how I call it, and like I've seen it in some other books using it as well. So for example, if we now start deleting punctuation, for example, from a spam message, right, we get a lot of random stuff flying in here, right? We have like the HTTP, then we can see, okay, we deleted some punctuation, we have the www, then we have like, it could be, the domain name could be unique, it could never come up in the data set again, so would not really be a distinctive feature, right? So this is why I'm showing, think first before you apply some text preprocessing. So what would be a better way of doing it? So here I give two other examples. So for example, in a review, we might also lose a bit of information. We lose the emojis, whereas in a new sample, it doesn't matter whether we delete punctuation or not. So what would be a smarter way of dealing with it is actually to normalize the text, how I call it. Just how you normalize numerical data, you can obviously also normalize text. So you can find patterns, right, like email addresses, HTTP addresses, money symbols, you name it, right? It obviously depends on your data, and then use regex to actually normalize it. And this way you actually already generate features, right? That's a part of feature generation. That now instead of having different domain names in every spam text, now you just have email address or web address, right? So very important. Then we talk about tokenization. Obviously, in the English language, it's rather straightforward. I introduced students to the NLTK package, which already has a word tokenizer in there, because the basic Python split is naive, right? It keeps the full stop at the end of a word, whereas NLTK is word tokenized. Another nice thing that I think I've never seen in a paper that actually uses Twitter data is NLTK tokenized actually as a tweet tokenizer, which actually keeps emojis and hashtags and stuff together. So that's another thing, right? So this just comes with experience. I think I've never seen this covered anywhere before. I actually myself stumbled upon it a couple of years ago by chance. So also really nice, right? Because this way you actually, again, you don't lose features and you don't lose information. Then we talk about stop word removal, which again, you need to experiment with it. You can't just say, oh, I pre-processed my text, I'll remove stop words. You need to verify, using a validation set whether any of your pre-processing actually makes sense. You can't just, suck it out of your fingers and say, okay, that seems logical to me, I'll just use it. You need to verify it. Again, as I said, will be covered in the next notebook. And then, yeah, obviously also which stop words list to use. Often you need to generate your own special stop word list. So again, when I was doing a project in legal tech and we were dealing with regularizations, obviously the stop word list we used was, was customized, right? Because all those regulations, they had like very specific legal lingo, like for example, the word paragraph that we just wanted to get rid of. So sometimes, again, you can't just use something that was already created and is out there. Sometimes you need to do it yourself. Then lemmatizing and stemming. So I talk about the differences between using NLTK and using Spacey, because NLTK is actually more annoying for lemmatizing because you also need to provide the information what type of word it is. So it only by default works with nouns. So again, you can sometimes tell when you read a research paper and then go into the code that they didn't know that, and they actually didn't properly lemmatize if they used lemmatization. So either use stemming. Again, verify what works better, whether there's a difference. If you want to lemmatize, use Spacey, because there you don't have that problem. Cool, and then after talking all those pre-processing, then we start talking about how to then, once you've pre-processed your text, how to actually then create numerical data out of it that you can feed into a machine learning model. So for those who are not familiar with the bag of words model, basically how it works is that you have a bag of words, which is all your vocabulary in your corpus, and then you create one hot encoded vectors, right? So if this is our vocabulary, then the word they will be encoded at the first position, we will be encoded at the second position, etc. Yeah, and then you can use either sum pooling or max pooling, to either just basically tick whether a word is present or not, or whether you also want to track the number of times it's present. Again, need to verify which one is better. Don't just use one and say, okay, that was my decision without actually basing it on some underlying evidence. Cool, then a few other things which again come with experience, or if you actually very good at reading documentation and not just skimming over it. So also something that I've realized way later than I would like to admit is that when you use then the count vectorizer or the IDF vectorizer from scikit-learn that it actually deletes punctuation and deletes single characters. So again, if people actually thought they did some cool pre-processing, thought they actually kept punctuation, and then they blindly use, just the count vectorizer without feeding in any parameters, they actually deleted it all. So again, read documentation. And so yeah, so this is what I show here, right? To see, look, you need to include the token pattern to make sure that it's not deleted, otherwise scikit-learn deletes it. Then we talk about the limitations of the bag of words model. Obviously, the bag of words model does not track the order of words. So two, opposite sentences could actually mean then, like in the bag of words model, would be represented the same way. And we cannot take new words into account, right? If it wasn't in our training corpus, then we don't have that information. Like, there's no way we can learn that word, so it will just not be accounted for. Cool. So that's intro to text preprocessing and the bag of words model. And then again, I break the lesson. Usually then I think it's kind of lunchtime. And after that, I ask people to write their own preprocessing function, which basically, it's just teaching them how to use those notebooks, because there's nothing super new here, but I want them then to engage with the notebook and find the information that they need, and they can just copy paste it and create their preprocessing function, right? And then it also has a solution, which again, it's up to you whether you walk through it or just let people then figure it out themselves. And then the fun stuff starts. So supervised machine learning 101, right? So I focus in this very first, breakthrough into NLP. I use classification as an example, because then you can also use, it to do something like that, like and also introduce them just to some fundamental machine learning and good practices. So I talk about what ML is, a few fun graphs, about the different types of machine learning, about the expectations and what we actually do as data scientists. And yeah, then about bias and variance, so all the fun stuff. So for regression versus classification, so in NLP, we are dealing with classification problems. And then how to deal with missing data, which in NLP kind of is, very different than to numerical data, but I still talk about it. But in NLP, I tell students, if you kind of just have a tweet missing, obviously there's just no way you can infer it. But if you actually want to, for example, generate more data, what you could do is you could translate it to another language and translate it back. That's one way of, for example, generating more data if you have one group which is underrepresented. Outliers, again, not really a thing in the specific, kind of tweet or text classification problem. But again, I'm talking about it because this kind of is not really NLP related. It's just machine learning 101. Then how to validate stuff correctly, right? So that you need a training set, a validation set, and a test set. If you don't have enough data, then maybe don't have a validation set, just use cross-validation. What cross-validation is, little graph here, right? So again, I'll not go into a lot of detail here because I'm sure you've all heard about this before. Different evaluation metrics, when to use accuracy, when to use F1 score, what kind of data, where is it more important to use precision, where is it more important to focus on recall, things like that. And then my favorite one, which literally is just never taught, and maybe you need to do a PhD for that, I don't know, but basically how to set a baseline correctly. So this is what I was talking about earlier, right? When I was talking about all those pre-processing stuff, that people just very rarely set a baseline correctly. If they base their work on another paper, that's fine, right? They say, okay, in that paper they did this and they achieved that. But if you actually have a new data set, and especially in research, right? If you're doing a PhD or you work in a research group, you actually collected some data and you even paid money and made people label it, and now you want to work with this data set and you want to do something with it, then you need to set it correctly, right? Because you have nothing else to compare it with. And so to use the example from previously, your baseline then should be using the raw text, right? It's okay, using the raw text and some specific machine learning model, classifier, whatever, I get baseline X. And then you start, iteratively, figuring out, okay, should I delete punctuation? Should I, generate features? Should I do this? And always verifying with a validation set, right? Setting the baseline aside, and then comparing it at the very end, whether it actually made sense to do all that. So, so I focus on that a lot. to really like make people understand that. And then again, old good scikit-learn, different, the label encoder, count vectorizer we already talked about, checking how balanced the data is, checking for missing data. So you see, this is what I meant. I mean, it has a lot of code, but you can literally just load in another data set, and it should all still work more or less. Obviously like changing the column names and things like that. And how to use pipelines in scikit-learn. Because, and then like what I talk about is, I'm not actually sure whether it's in this notebook, is about data leakage, right? Especially in the bag of words model. So scikit-learn pipelines, they take care of that, right? So that you don't actually learn the whole vocabulary and then start splitting, right? When you actually already cheated because you learned the whole vocabulary. So I make sure that people know what a pipeline is, know why they should use it, and not just use everything separately and then apply it one by one. Cool, yeah, how to set a baseline, for example, with naive Bayes, maybe to start with, right? How to interpret a confusion matrix, how to print out a classification report, how to use different models that in scikit-learn are just super easy and nicely to import. Short introduction of what each one is, how to use cross-validation. So because we set a baseline, right, we set it aside, that piece of data, now we're using cross-validation, and what a multi-layer perceptron is. So, and then the exercise would be, if there's still time, just play around with it, compare all those different models, and make a decision and compare it to the baseline. Did it perform better or not? Cool. So that concludes day one. Right. So this is like a sample. Sorry, I forgot to show it at the beginning. So this would be like like a 2-day program, right? So we would have what is NLP, introduction to Python. The practical, then lunch, getting started, another practical, machine learning fundamentals, and that kind of like concludes the day for that day. And then because it's the UK, people just go for drinks and forget everything they learned. Then day 2. So day 2, at least like the way I do it, is that because if people got too drunk the night before, then nobody's there at 10 a.m. straight. So you start with an exercise again, and just see whether people, eventually show up or not, because nobody is there at 9 or 10 straight. So you just say, okay, now based on what you've learned the day before, write your own classifier, right? So use a data set. It doesn't have to be this one. This is just an example, and then set up a baseline. Read in, use the count vectorizer, experiment with in like the n-gram range and like other parameters of the count vectorizer. For example, there's a minimum count that you can set for words. This way you can, for example, get rid of all unique tokens, because unique tokens don't contain any value, right? Because they are not distinctive features. So you can already start cleaning with the help of the count vectorizer, and you don't have to do it yourself using collections and counter and stuff like that. Yeah, there is no solution for this because it's all going to be covered in a case study, which usually then is the live coding session. I just ask people, did anybody of you find a cool data set? I give them like a bit of time, or they do it already here, right, while they do the practical, and this is then where there is like a live coding session. Then what I do is I actually talk in depth about 2 machine learning algorithms, so that it's not just, which again is a problem, what I've encountered with many of those online courses, is that it kind of treats it as a black box. It's like, yeah, just import KNN, just import MLP, just import whatever, but they actually don't really go into depth of any of those algorithms. Or it's the other extreme, and it's just too much maths, and and then people again get scared off. So I want to strike a good balance. So now already you know at least how to import stuff, and now let's actually talk about 2 algorithms that are more or less straightforward to understand, especially naive Bayes, in more detail. So here I took, as I said, I took a naive Bayes as an example because it's just very, very easy to explain using an example and just basic maths from high school, right? So I talked to them about, okay, let's assume you have a corpus of data. Obviously, here in this case, it's a really, really small one. Like, yeah, what grade match? The election results will be out tomorrow. the match was very boring. It was a close selection. So labels, sports, not sports, sports, not sports. Then we make it even easier and say, hey, let's assume you removed stop words. This is your corpus, right? It just contains a couple of words. And now, how do we train a naive Bayes? So prior, we have 2 sports, 2 non-sports articles. Then, how to get the likelihood, right? How to calculate that. And then we talk about, okay, but what if a word actually isn't present? Then, your likelihood becomes 0. So this is where smoothing comes in. So I showed them, because like, I want people, again, obviously in scikit-learn this already happens in the background, like they will add smoothing for you. But I want people to, to understand that, okay, you should really understand an algorithm and not just blindly import stuff, and because then you will never be able to debug it if you just don't understand how something works. So for example, naive Bayes, right, is the prior is too small. It doesn't really work well for imbalanced data sets, right? So again, just to show people that, please don't treat everything as a black box like a lot of courses do. And then the complete example, like the maths, and then the same implementation in scikit-learn for naive Bayes. Then I do the same for logistic regression. I apologize for those really ugly pictures. I did it on my old tablet. I still need to update them. But basically, then I talk about, the different, what a word embed, well, we'll talk about word embeddings in a bit, but what a word vector is, and then how word vectors are kind of like represented and how we need to learn the weights in order to then get the score, in order to, calculate whether something belongs to one group or the other, show them like a graphical representation of what we're interested in, right, to create the hyperplane that splits one group from the other. So again, what the loss function is, because again, in naive Bayes, you don't have a loss function. I do have another materials for an ML course where I actually go into depth about a gradient descent. Here I'm kind of skipping it, but I still don't want to like completely ignore it. So then, so here I'm saying, okay, so you see for naive Bayes, it's just a calculation. That's why naive Bayes is actually also really fast. There is actually no machine learning happening in there, whereas logistic regression is a different scenario. You have a loss function, you need to minimize the loss, and then you use an algorithm called gradient descent in order to, continue minimizing it until you find the optimal minimum. So this is like, again, a little, teaser on actual machine learning, and then people can go away and do more reading and more, like self-study on that. An example on how to use logistic regression, again, using the same example. And then how to actually analyze coefficients in, probability scores and coefficients in, do we do coefficients? Yeah. And coefficients of different words, right? So for example, here for business, the words with the highest coefficient are firm, euros, shares, bank. Makes sense, right? And then for entertainment, it would be film, singer, TV, etc. So this way they can actually like see an example, put it into perspective, what like the abstract things that I talked about before, like the scores and the word vectors. Yeah, and that concludes that. Then Then I talk about word embeddings, because you can't really teach an NLP course and be like, yeah, we only did one hot encoded vectors. However, like we don't use them. Like in the live coding session, like we don't use word embeddings. We use the one hot encoded vectors that we talked about before, but still I want people to be aware of them, obviously, because then after this, because this is kind of like their base, right? And then after that, if they want to go deeper and actually go and start exploring transformer models, sequence-to-sequence models, generative AI, etc., then you can't really not know what a word embedding is. So I took a lot of materials from the book by Juravsky, so you will maybe see some familiar pictures, not sure. So how I introduce it is, well, in hot encoded vectors, right, all the vectors are independent from each other. They're all showing into different directions. So this is why we need word embeddings. Then it was actually a student of mine who created this cute little graph. that's actually, we want something similar to this, right? So, okay, we want fridge to be completely, like, well, not complete, but want to be kind of like unrelated and independent maybe from cat, but we actually do want cat and kitten to show kind of in a similar direction, right? So this is how we would also then address one of the limitations of the bag of words model that we talked about during the very first session, that now we can actually put things into relation, whereas in bag of words you can't do that. So then we talk about different vectorizers. So this is where like the inspiration is purely from Joravsky's book, because I really liked it. So we have the classical one, hot encoded vectors that we already talked about. So I'm not wasting too much time here going over that again. Then we talk about the term document matrix. And there was a nice example in the book by like using Shakespeare plays, Julius Caesar and Henry V, and that you can, kind of like generate, like document vectors, right? By checking how often certain words appear in a document, or like in a book or in a play. So for example, As You Like It and Twelfth Night, they have the word fool very often, but the word battle they don't. And so when you have like bigger documents, exactly the same, just that we can't plot it behind 3 dimensions, right? But this is basically how it works. This is how you can find similar documents, just by comparing basically how often certain words co-occur with each other. Or like which words occur and which ones don't. And then you have, this way you can also kind of already like create like word similarity measures, right? So we can kind of see that the vectors fool and wit are more closely related to each other, like they look more similar, right, based on the numbers than, for example, like good and battle. But obviously, not really a great way of doing it, given that, if you have like a really big book and a really small book, obviously like the numbers will differ, even though they might be, from a similar genre. So another way, then this is where we already get closer, in order to like, spoon feed them later, how, for example, how Skipcar model works is, by talking about co-occurrences of words, like the term matrix, right? And then we can see, for example, that the word digital and computer occur more often together than, for example, the word digital and sugar, right? So this way, again, we already like introduce the definition of like a context window, right? So to use a context of, for example, plus minus 4 words, and most likely, similar words will co-occur together. Yeah, so that's that. And then I start talking about word embeddings. So again, what is a one hot encoded word? We have, for example, a 1 for queen, right? So this word, like this, this is the representation, one hot representation of the word queen. But what do we actually want in order to capture similarity? So we want something similar to this, right? And again, obviously this is not how a computer works. It doesn't like tell us, okay, the first number stands for royalty, the second for masculinity, etc. But this is, again, this is more or less how word embeddings work. And so, so for example, for royalty, king and queen and princess will have higher values, but for woman, not, right? Because woman is not royal. Masculinity, king and queen, king will have a high score, woman, princess and queen will not, etc. But so this way we can already capture similarity, right? So this is what we want. So basically we want to get from here to here. And that's the difference between, just a one hot encoded vector and an actual word embedding. And then, okay, the famous example, right, which actually only works in perfect conditions, we all know that, but theoretically, you should be able to do vector maths, right, if you have word embeddings, right? Because you could, for example, take the vector for king, add the vector for woman, and you will get to queen, right? Again, famous example from Word2Vec paper. Obviously, it does not always work like that, but theoretically, this is what we would like to be able to do. Then I very quickly talk about static versus contextual word embeddings. So obviously, contextual word embeddings are not within the scope of this little workshop. So I'm not talking about, again, transformer models, BERT, etc. but I still, like, again, mention it so that people then can go and do their own research, or, you know, start, like, do maybe another course, a more advanced one. But I do talk about word2vec because the algorithm is, you know, quite straightforward and simple to follow, and we already, like, gave all the prerequisites for that, right? So we talked very quickly, we talked about an NLP, where we showed that it had a hidden layer that can, like, learns the weights. We introduced a context window that, like the shifting context window that can capture context. And so, yeah, so I talk about word2vec, the two algorithms, the skipgram and continuous bag of words, right? That you either feed in the context and you want to predict the word in the middle, or you give the word and you want to predict the context. And using, you know, a neural network architecture for that, you can, you know, you learn the weights, right? And these weights in the hidden layer become your word embeddings. And then, because again, I mean, I do still want them to use them, and not just, again, because I don't like stuff that is, like, super theoretical, but people can't actually apply it, then we actually also, like, train our own word embeddings. But we are not using them to then feed them as, like, into, you know, into a more complicated architecture. We just use them to show cosine, like to use cosine similarity, because again, it's simple, it's easy to follow, and again, you know, you can play around with it. And so, for example, one example that I give: imagine you have a chatbot for IT support, and then, you know, somebody types something in, and then you could use cosine similarity maybe to then extract something from the database that somebody else already asked, which is very similar. Like, I don't know, my internet doesn't work. But then somebody else says, I don't know, my router doesn't connect, something like that. And that these sentences will be more similar than something that has nothing to do with the internet. So, yeah, this is where we use GenSim, and we use, again, the BBC data set in order to then train word embeddings, right? Then in GenSim, you have something nice which is called phrases. So if something actually appears very, very often together, you can actually create, like, a feature. You can create a token with those phrases, and then replace the co-occurrences with those phrases. And then we can train a model. So using, I deleted stop words just to, yeah, for demo purposes, so that doesn't take that long. The parameters of the how to build a word2vec model. So the minimum count, right, which is the word co-occurrence in the corpus. Then the window, what we talked about earlier, +/-4, +/-3. Again, you can experiment with that. The vector size, how long you actually want your vectors to be, and how many cores you want to use while doing that. And then, yeah, so this way you can train your own word embeddings. And so this is how they look, right? So very, very different from what we're used to from the first couple of lectures, right? So for example, here, that's the word vector for football. And I talk about that, you know, every time you run the notebook, they will be different, right? Because the weights in the model are initialized randomly. So, and then also, again, logically from that follows that you trained your own word embedding now using your corpus, so it will only work for you and this corpus, right? You can't then take, like, some downloaded ones and then wonder, oh, why is the vector for football so different from my vector for football? So this is really nice for stuff where you have, like, your own corpora, right? So for example, again, if you're dealing with legal text, maybe worth training your own word embeddings instead of downloading something that was trained on Google News or something like that. So this is where we talk about that depending on the topic and the problem at hand, you might either want to train your own word embeddings or use pre-trained ones. And so they can also download the pre-trained ones. I'm not going to do that now. It's the word2vec Google News word embeddings, right? They were of a size 300. And then again, like I showed them, that this vector will obviously look very, very different because it was trained on a very different data set, much more data than, and well, again, weights are randomly initialized. And that you can only do then comparisons of similarity, you know, using obviously the same word vectors from the same corpus. Okay, that's that. Can I close it? Thank you. And then we talk about, applications, right? So for example, you can use cosine similarity. in order to calculate the cosine between two vectors, and this way you can tell, as we saw in the example with the cat and the kitten, right, how close, like how similar the direction is into which they point. So here, for example, we can see that the between the value between ball and match is much higher than, for example, between match and president. And then obviously the question comes up, okay, but how do you do it between documents? And so here, this is where I talk about the fact that, okay, in order to, again, doing it the naive way, because the non-naive way is out of the scope of this little course. The naive way is just to average them out. But obviously this has also its limitations, right? Because once you did that, you cannot get back to the individual vectors. So you could actually have like some very different numbers here, but you would generate the same. Like if you would average it out, it would generate the same number, but the vectors could be very different. However, in the models that we cover here, like that you use in scikit-learn, there is no way to use to feed in something sequentially. So you need to somehow, like we did with the with the max and with the sum pooling, with the one hot encoded vectors, we need to do something similar with the word embeddings. However, I mean, again, it depends on your task. It might actually work quite well. So we create the weighted sum, and this way we can actually then calculate the weighted sum of the document word embedding, and I used like the weighted sum of 3 documents. What were the 3 documents? I think, business article and 2 sports articles. And then again, I show them that the 2 sport articles will have a high similarity than when you compare the sports article with the business article. And now they know how to use word embeddings. And then a comparison between, you could argue, okay, but we could still use a cosine similarity for one hot encoded vectors. Of course you can, right? But as an example, we have 2 sentences. Since I enjoy spending time with animals, I decided to buy a dog. And we have, you're thinking of adopting a cat because you like pets, right? So you see there's absolutely no overlap between those 2 sentences. So it will give you a cosine similarity of 0 if you use one hot encoded vectors. However, if you use the word embeddings, you actually get a similarity of 0.7. And here we get 0, right? Because there are just no overlapping words. And this kind of concludes it. And this way they have like a nice little, base for then continuing their NLP journey. And then, as I said, what I do usually is, and this is actually, we can do that together now, is that I do a live coding session, like from scratch. I mean, I do have like something on my other screen, right, so that I don't waste too much time, with typos and stuff. But, and I also try to change it up each year. Either I obviously have some backups, so do your homework if you're actually going to be teaching. Have some interesting data sets, because if people are very new to this, they also sometimes struggle just to find something cool where actually stuff works. But usually then again, I also ask whether somebody has whether somebody found some interesting data sets, something they want to cover specifically. Sometimes I have people that have ideas because of work, because they're working professionals, and they say, oh, I'm dealing with this kind of data, can we maybe do something with that? Or with something similar, which is obviously like not proprietary and available online. And then we just apply the stuff that we have learned. So very simple little data set from Kaggle. It's disaster tweets. I think it's even like considered, like a natural language was like my first project or something like that, right? So getting started with competitions. So, because again, I tell them it doesn't matter whether then you somehow get you have bad results in your baseline and you get amazing results. All I want you to do is get your hands dirty so you know how to do it, and also to have a template, right? Because that's the beauty of this. Once you have a good template, then you can just always open it from on another screen and just copy paste or follow the same steps that you did before. So I downloaded the data set, and then first just sanity checking. What is missing? Do we have missing data? I usually use the Seaborn library. Okay, location. We have apparently we have quite a few columns. We have an ID, we have keywords where we actually don't know how they were extracted, location, text, and the target. And we can see, well, location is missing, probably not worth using that column. Then we really, again, check whether we really have two classes as we expect, disaster and non-disaster, because again, maybe there's some, some mistake, or your data is, I don't know, got corrupted, so just sanity checking. Then we check for the distributions to see, are we dealing with more or less a balanced data set, because that can obviously also, then that affects model choice and also baseline choice. If it's completely unbalanced, it's kind of, maybe don't use naive Bayes as a baseline, because then, you'll get a crappy baseline, and then everything else will be perfect. Then maybe use a different model that isn't as affected by imbalanced data sets. Then we set, because it's a Kaggle challenge, then we already have a test set, right? And we don't have targets for it. So the way we set our baseline is we use a naive Bayes in this case. Without doing anything to the text, without doing any pre-processing and nothing, we apply it, and then we upload it to Kaggle, and we see. And this is our baseline in this case. If it wasn't a Kaggle competition, then, as we learned it in the previous notebooks, then you have you decide whether you have a train and a validation set, or you just use cross-validation. You take a test set aside, and you really just apply it once, and then you put it away until the end, right? And base all your further decisions on the validation set or on the or using cross-validation. So you upload it to Kaggle, and a Kaggle competition baseline with a multinomial naive Bayes without doing anything to the data is around 80%. So now, for all the other decisions, we need to use cross-validation or set a validation set aside, right? And now we can start experimenting with the parameters of the vectorizer, for example, right? Or with pre-processing. And so here, this is usually where I spend some time, going through different values. For example, should it be true or false? So that's, whether we want to use max pooling or sum pooling. How many times do we want a word to appear in the data set? So usually it should be set to minimum 2 anyway. Do we want to delete punctuation or not, right? Do we want to include the token pattern, that we include, everything, and don't let the scikit-learn count vectorizer delete anything, right? And then, you rerun this code with different combinations. I mean, you can do it manually. You can, do a grid search. I'm doing it manually just to show people that the number here changes. And this is what I mean with, setting a baseline correctly. That, don't just blindly apply some pre-processing, because it will be different for every data set. Then you can also experiment with different vectorizers. So these are all parameters in your overall model, right, that people sometimes just ignore for some reason. And then just really focus on feature engineering, whatever, but you already actually didn't check whether, as I said, maybe including stop words is a better decision than deleting it. Cool. Then we again, importing different classifiers, seeing whether that changes anything. So usually, my go-to ones are support vector machine, KNN, a decision tree, and an MLP. You, again, try them out and see, whether any of them gives you a better result than before. Then obviously I try to choose one which actually has a few hyperparameters to tune. So that's usually, how I also have my backup data sets where, K and N hyperparameter tuning is really boring, right? Because you only have the K. But I usually try to choose choose a data set where one of the more, let's call it sophisticated models, perform a bit better, to actually talk about hyperparameters as well and how to tune them. So usually I go for logistic regression or support vector machine. MLP I also try to tend to avoid, because it's quite boring just reiterating all the different hidden layer sizes and neuron sizes, and it can take a really, really long time, and you don't really want to stand there for 20, 30 minutes, and depending on the size of the data set. So usually, just from my personal experience, choose logistic regression or support vector machine. Cool. Then what else can we do? We can actually, again, get our hands dirty and analyze a data also qualitatively, right? So instead of, just focusing, oh, this model did this, and oh, I was getting hooked up on hyperparameters, maybe also have a look at your data to see actually what went wrong. Because again, you will have, I've noticed, I was supporting a student a couple of months ago with her master thesis, and she found a data set in Hindi for fake news detection, and we couldn't really get our accuracy much higher for the model that we used. We also used, different more sophisticated models. We use transformers as well. And then when you actually, I don't speak Hindi, but she did. But when you actually then go into your data, there was just mislabeled data, like a lot. So again, it's not always your fault or the algorithm's fault. I mean, also please qualitatively engage with your data, which also quite often people don't do when you read research papers, right? Because again, maybe it wasn't actually the model, maybe you had just bad labelers, and maybe you also didn't follow a proper labeling paradigm, right? Who actually was labeling the data? Did you actually did you analyze how people, I forgot the word for it, inter-annotator agreement? Did you actually measure that? Because quite often they don't. They just either, I mean, if they quite often it's just the researchers themselves who do it. They don't even, especially if you if you don't have that much funding and can't really outsource it to Amazon Mechanical Turk or those other platforms. And then it's like, okay, but who actually verified how good your labels are? So yeah, saving wrong predictions into a file for analysis. Confusion matrix, all the good stuff. Then we talk about hyperparameters. So again, because we chose sport vector machine, we can search for a more optimal C and try out different kernels. So this is also where I introduce regularization. What is regularization? Why you should use it? Especially if you have badly labeled data, then maybe you actually should use more regularization and not trust your data so much. So this is where I talk about that. And then you try it on a test set and you upload it back to Kaggle. And then obviously, depending on how much time you have, you can go nuts. And for example, use what I also like doing is, especially if the group is a bit stronger and have more coding experience, you can use Spacey for named entity recognition, and then maybe introduce additional features like, ooh, it has a location, right? Or it has some other named entities, and generate features like that. What else? What I also like doing, but I don't have it as a notebook, but I have it as additional code, again, if the group is stronger, or if I use it with private clients. I also feed in the same data into a more sophisticated model, and then we compare. And what is quite fun is when actually the sophisticated model isn't much better. And then you're kind of like, oh, look, deep learning is not a magic pill, haha. Yeah, so that's that. So this is usually really up to you how you, whether you just do it like I did now and spoon feed them with a data set, or whether you actually ask people to provide you with something. That's that. And then I talk about some other additional stuff which people then can either look in. So first, additional resources. So again, I created those notebooks, as I said, in order to address certain shortcomings that I've noticed in other online courses. But I will not create content from scratch, which is already really good somewhere else. So there is, so again, that's literally just for you, if you're ever actually either gonna learn it yourself or teach it, some cool links to let me see whether I find the one that I wanted to show you. I really like this guy. Maybe you've heard of him. It's StatQuest. I can't remember which uni he is. He's some lecturer at some uni. His videos and his explanations are amazing. There's no point me wasting time if I can just show this video, reference this video. So this guy, for basic ML stuff, it's a gold mine. So yeah, so some links to that. But I mean, I only included the links for the stuff that we've covered, like naive Bayes logistic regression. But then obviously you can then just in general just check him out. And so this is how I just provide my students some additional resources, so they don't go and pay some weird data science course if there's a lot of materials and good content already online. So PCA step by step, see cross validation, and his animations are just spot on. So yeah, big fan. Don't waste your time, explaining something or creating content if you've already found something good online. Some links to courses. So I really just again, you will not become a scikit-learn expert just because you watch a video, but sometimes it's just good, to have a longer one for 4 hours that also runs you similar to what I did here through a whole pipeline, right? How you do the pre-processing, how you do normalization, scaling, if we're not talking about NLP, then feeding it into the model, etc. So basically just, this you can adjust. If you have some amazing content, please put it out and please share it with your students. Then proposal. So each year I collect like ideas or just wishes of what people would like to cover on an online course. So what I really like topic modeling using Top2Vec because again, just from my personal experience, it works quite well. I used it for a project, and then paper to it, and then and I get this again, like as I already said previously, it is a very common problem that people want to address is named entity recognition. And in Spacey, doing named entity recognition is also beautiful, like easy. And so I show here what that means, right? That you have some text and that, by using Spacey, you can get quite a few entities out of it. But what if you want, so here you can see a visualization of that. But what if you want your own ones, right? As I said, what if I wanted, so for example, in my legal tech job, we were interested in certain drugs. I mean, that's a bad example, there were like more, but we had like homeopathic, certain vaccines, certain other stuff. And, the dictionary was, I mean, we also wanted it to generalize more, right? So we didn't want to just use, check if word is in, but we wanted it to generalize. So we trained a custom named entity recognition classifier. So again, and in Spacey is also beautifully documented. It's just so nice to use. So this is also something that I could cover, but I would not need 2 days for that, right? So it's like a 2-3 hour thing. So yeah, so also for you guys, if you're interested, there's a form here that you can fill out. Then there is my LinkedIn, my websites. And yeah, and that's kind of concludes it. We still have quite a bit of time. So if you either want to go over something in more detail, or if you just want to have like a longer Q&A session, or just go and grab some food, that's up to you. But I will give now the word to you guys. Thank you very much for hanging in here for an hour. And yeah. Thank you. Oh, yeah.
On the internet, so if there is none, then
So can I ask a question?
Yeah, of course.
So for some model like that,
Yeah, sorry.
We have some models like that. Do we need to remove the stop words in the train data?
For BERT, no. Because BERT is a contextual model. So it actually you need to keep the stop words. But what you can, for example, do is, again, if you have typos in there or rare words, then you could, for example, remove those, right? But to give you an example, like a certain hashtag or something in Twitter data. But no, in BERT, you do like very minimal, or like in other transformer models, you do very minimal pre-processing.
Do we need the normalization step for training data?
That's a good question. I would do it. For normalization, yeah. Because again, like because again, at the end of the day, BERT is not a human being. We don't need to make sure that BERT understands that something is a URL. So actually doing like the normalization, like saying that, oh, this is an HTTP address, so that it can, learn that feature, I would do that.
So if we can find emails or links, we need to remove them and put it a kind of label instead of that?
Exactly. So that's what I did here. But again, so this is why I was like kind of like religiously saying throughout the talk, always validate. You try it with and you try it without and see what works better. Right? I'm not telling you now, oh, this is how you need to do it, right? Because it depends on the data set. So set a baseline without touching anything and then try different pre-processing techniques and see whether it performs better. Yeah, that's yeah.
Can you maybe tell us a little bit about some common difficulties you have when teaching people like these NLP concepts? Like, are there any topics that you find especially difficult to teach, or that you think people have difficulties to wrap their mind around?
So it depends on the setting. So I can tell you, so because I was teaching at university a lot, I was teaching a data science, so it was not NLP, it was data science, summer school a couple of years ago at UCL. And we had a lot of people from Asia. And they, it's a bit like there's a cultural difference between, certain, different cultures that they kind of, they don't immediately understand that there's no one solution fits all approach. Like they see this and then they follow it step by step without, actually trying out like different things. And this is also what, I tried to tell you guys earlier, right? There are different types of data. Use logical common sense, deciding on, whether you want to remove punctuation, for example, or not, whether it makes sense. But they want like a very strict, first you do this, then you do this, then you do that. And you kind of need to you need to explain to them, no, you need to experiment and try things out. There is no one solution fits all approach. So I think, but it's like that for every topic. Like it just comes with experience. At the beginning, it's obviously easier just to follow a certain number of steps, and instead of, using your experience and common sense to make decisions, as one example.
What kind of use cases do you have in law, document processing? Like, what do you typically want to achieve?
I'll give you some examples, as I said, from a previous project I worked on. So there we actually used a lot of linguistics to get information out. To give you an example, grammar is actually quite logical and structural. So we were trying to get out which part of a regulation applies to which kind of drug. This is why we were trying to identify first the drugs, because EU regulations or UK regulations, not like you have a regulation for each type of drug. You have like the Medical Act of whatever, 1994, right? And it talks about a lot of different medicines. Then first you use a named entity classifier to find the paragraphs that talk about certain drugs. And then we used parse trees in order to find out whether a paragraph applies or doesn't apply to a product. So for example, this paragraph applies to homeopathic drugs, comma, but doesn't apply to, and then by, building those like your grammar rules, you can extract information out like that. So quite manual, but it works.
And then at the end, the use case is that a user is interested to figure out how a drug
exactly. So for example, a medical lab comes up with a new drug, but we are too poor to hire a lawyer, or we just want to get like a first impression of, okay, which paragraphs do we need to be aware of, which regulations do we need to follow, instead of, like reading the Medical Act from start to finish. So that was one thing that we used. Another thing we used, so this is why I had like those two examples up there, we were working with DEFRA, which is a department, like an environmental department in the UK. And they already had some regulations that they said, oh, these regulations, they have something to do with climate. So they address water safety or air pollution. Can you find more? And then use topic modeling. And you check those regulations in which topic clusters they are, and then check the documents around them, because most likely they will be like quite similar. And this way you find more regulations that apply to air pollution, water safety, etc. So these were like two things that we were working on.
Coming back to the first example for drug regulations, do you think it would be possible to like further extend the NLP process in order to create a like mathematical model or something that automatically can distinguish between this drug, can put it into a model that creates like an interface for doing something with this information. Do you know what I mean?
I mean, regarding interface, that was not my thing. That was outsourced to the Eastern Europeans, who they made a pretty interface. But no, I'm kidding. So what you're talking about, like. Obviously, another big thing in law is actually finding out whether, for example, what exactly is an argument, what exactly is the justification, what exactly is an example, why a certain decision was made, right? And there, I mean, you need a lot of label data for that, right? And then, like, it's you can't really go really far, using, like a manual approach like that, following a path tree. So we want, for example, like another startup that I'm sometimes supporting, they actually want to, have labeled data for which trial was successful and which wasn't. Right? And then you just need labeled data and really powerful contextual models that can distinguish between like, oh, this trial and this trial, what are the similarities? You can't just use an approach like, oh, this paragraph applies to, right? You have actually like one is one was a homicide and one was a murder. Two different decisions were reached. Why? And then you have a third case. And then which one is the one that you should apply, right? Should this be a successful outcome or not?
It's probably very hard to validate too, right?
Yeah. So that's just law specific. That's a big thing that people are working on right now. Any more questions? Yeah.
I have a question about chatbots.
Mm-hmm.
Basics of making a chatbot like a simple one, not as sophisticated as GPT.
Okay.
Like, or how to tell in terms of the methods that you show us, that we've seen, like how to introduce people into
chatbots.
Into chatbots.
It's a good question because I did my PhD on that. It's a very simple one, right? There are two ways. And both of them are actually covered, right? So either you have a chatbot and you have like some sort of data. How you get it is up to you. I actually recruited people, right? Because there was no data set available. So I had to like collect like, basically the knowledge base of the chatbot, right? Like potential questions that the user might have and potential answers. And then there are two ways of doing that, right? Then one way is using cosine similarity, right? Saying, okay, if this, well, no, actually, the most simple way is just if-else statement, right? You connect them all, and it's like, oh, if this question comes in, right, or a similar one, then reply with this, yeah? Or, again, you use cosine similarity. Okay, this question is similar to another one. I know that we need to answer with that one. You measure the similarity. Then that's one way. The second way is you could train a classifier. Right? And so to give you an example, my very last paper was on a chatbot that tried to convince people to get the COVID vaccine.
Yeah.
And
how to do that?
Yeah, exactly, how to do that. And because there was not a lot, and still, like, there is not that much information on, like, no, people are not that informed. People have like very specific reasons why they don't want to take the vaccine. So and they weren't super sophisticated and well researched. It was just like, it was developed too fast. It will affect my fertility. That was a common one with women. So it was always, they used kind of the same keywords or somehow like the same ways of expressing it. And then you could just label it, right? And say, issue fertility, issue chipping, issue to develop too fast, right? And we call this concerns, right? Concerns that people have. And you could train a classifier that classifies the concern and then tries to reply with a counter argument to address your concern.
That means once it sees the keyword like chipping and
yeah, exactly.
Talking about it.
Yeah, exactly. So yeah, I mean, but keywords would be like very similar, would be just like a control F, right? But sometimes people would use different words. So for example, they could use side effects, but then they could use, what was another word they used? There was another one, right? So the words would be different. And then obviously if you have a classifier that you trained the
5G,
data.
for example.
Yeah, exactly. And then for deployment, I was thinking also once making a tutorial about it, because actually it's very easy to deploy in Telegram. I really like it. I mean, I didn't because I mean, there's still like, then you have the boundary of people needing to have Telegram, so it's easier just to have a website on a server. But on Telegram, it's actually really nice. A really good API, and then you can host it there just for fun. You just use something like DigitalOcean as a server, right? And then you just, yeah, it's very neat. I'm not sure whether they've done it before. They have like the bot father, right? And then you create your, yeah, it's really neat. I have to admit that.
Thank you.
Yeah.
You mentioned for generating more data, we need to translate our trained data to...
That's one idea. That's what I once did an interview, and the guy came up with that, and I was like, oh, that's actually really cool. That's a good idea.
Okay, so if I have a medical data, so it is sensitive, which kind of model do you suggest?
That's a good question. I mean, I would probably just buy an API, right? that, I mean, don't post it into Google Translate. I think DeepL has an API. I'm not sure whether they're storing it. You would need to literally just read their like terms and conditions, right? Whether you should be using their
Maybe there
translation.
are some models like T5.
Mm-hmm.
I don't know. I'm not sure about the model.
I'm not sure either, to be honest. I have not dealt a lot with translation. Yeah, I mean, probably you could train your own translator. I'm not sure I would do that and go through the hassle. I'm sure there are like translators you could use with decent terms and conditions that will not store your medical data. Or you could anonymize it, right? So in medical data, that's also like a big topic that you actually, even for your models, you don't want to have any names and stuff in there or any like personal identifiable information. So that's another area of research, how to actually, anonymize data properly. So it's not just about finding Mr. and Mrs., right? But if you actually, for example, know the location, it's a very small village, and you say it was somebody of, again, certain descent. If there's only one person of that descent living in that village, well, then it's kind of obvious who it is, right? So.
Thank you.
Cool. Okay, guys, I mean, we still have 10 minutes. I'll be hanging around here, so if you have any questions that you don't want to be recorded, find me. So yeah, but still, thank you very much for coming to my talk. I really appreciate it.